Welcome students to Sustainable Hydrology. During the first weeks we got familiar with brine space and we also saw all the principles and basic concepts of sustainable hydrology, and we applied these concepts into active discussions online. Now let's see what we have for week number 5. If we go to brine space, we will find week number 5, and we will see the introduction, lecture, and the activities that we have for this week. For this week we have the first online quiz, and in the introduction we will see all the objectives for this week. So we're going to learn about stormwater runoff, stormwater management techniques, and study the impact of urban land uses on hydrological cycles, as well as the impact of agricultural land uses on the hydrological cycle. And we will review the first 2 weeks. We will assess that in the online quiz. So let's review that. What we are going to see in this week, what we can expect to see in the online quiz number 1. So each week we have the lecture, and in the lecture I summarize the most important points. So we saw the basic principles, this is lecture number 1, basic principles and concepts of hydrology. So I could recommend you to review these concepts, these definitions. I know they are very basic, you know that from high school and even before that, but it's important to have these basic concepts clear for sustainable hydrology. So I could recommend you to review this lecture, especially these definitions, as well as the hydrologic equation. Understand what it means, what is the balance of the hydrological cycle, how can we understand this phenomenon, which is the inflow of water minus the outflow, and that is equal to the change in storage. So this is in very general sense what is the hydrologic equation. So please review these concepts as well. This energy transformation is important to keep in mind, but it's not gonna be tested and not gonna be assessed in the quiz. And here it's important to review these concepts to know what is the percentage of fresh water and where is this fresh water concentrated in our planet, because that's our main point of distribution of water in the planet. So it's important to review these values and concepts. And for this week I could say those are the main points to be focused on. For lecture 2, for week number 2, you can review the summary in lecture 2, and please read it through again. This is a continuation of the basic concepts of hydrologic cycle from week 1. Review these definitions, and also please, this is the most important point of week number 2. Review please the concept of watershed management. For example, if you have a problem like deficient water supplies, what could be the possible alternative solutions? So, or if you have a flooding, what could be the potential? So now, after seeing the basic concepts of the hydrologic cycle, here in week 2, we can start identifying problems and think about possible alternative solutions using watershed management. So please review specifically this table. It's important to have clear concepts of water table, what is the water table, and I think that's it in this week. That's the main point, watershed management and groundwater for this week. For week number 3, I could recommend you to go again to lecture 3, where it's all the summary, all the details, and try to put what is most important to continue building up the concepts and the knowledge that we're gaining in this course. So every week is going to use the knowledge and concepts that we saw in the previous week. So for example, for this one, now we apply watershed concepts. We saw watershed here and management of watersheds, and here we apply these concepts. And there is a very important document. I usually put links in through the lectures. You don't need to read them all, but it's important that you click on them and you give them a glance. You are aware of those. This one is a special one and it's very important. That's why I put it in the first paragraph of lecture number 3, because is a landmark in the water policies for Ontario and I would say for Canada. So please review this, especially the part of multivariate approach. How did it happen? Why did it happen? What was the history behind this? Uh, how did it appear and what it means, that multivariate approach to protecting drinking water. In the next weeks, we will see more in detail drinking water and water quality. But for now, it's important to know this part. In this week, you can review this material, and I would recommend to see watershed planning. And that could be all that you need to study for this week. As I mentioned, click on the links. You don't need to read them all through, but just be aware of what it is. What is that public involvement in watershed management? What it means. And as I mentioned, this is the most important, and that's why the first link is about the what happened in Walkerton, Ontario in May 2000. For week 4, we are building up more concepts, and now we are estimating and we are calculating peak flows and uh, all the drainage and water, all the discharge of water. So here I presented an introduction to hydrographs. So definition, just to have a general idea, please review these concepts, especially what is an infiltration, interflow, water table from week 2 as well. So it's clear. Here is very well summarized, so please read through these, and especially these tips for the calculation. The calculations are very simple. It's just a multiplication, but you need to have clear all the concepts. I mentioned here, please study this presentation, which explains all the details about this. So please click on these hydrographs, and here you will find all the basic information that we need to calculate that. What is this charge? Please keep in mind the definition, review these units, the factors that affect this charge. What is the difference in a very slow change? Which factors are imply that there is a change in a long term? This is relative because sometimes we can have extreme events, an earthquake or something that can change the watershed, and that could be really quick. But in general sense, these variables change slowly over longer periods of time. And these, on the other hand, precipitation seasons and other climate-related variables, such as temperature, humidity, they change a little bit faster, so they change over shorter periods of time. So it's important to identify which are the variable and how they change over the time. These are important concepts to identify. We need to know what is interception, evaporation, identify what is an interflow, what it means that in the what it does mean that when I talk about interflow, there is a clear diagram here that I put it so we can understand that this is highly permeable water zone. So this is an area that is not saturated with water and is highly permeable. And here we have the interflow. So review these concepts, why we have infiltration, why do we have this zone of interflow, and what is this part? This is all high I'm sorry, this is high permeable, this is low permeability bedrock, and here we have all the water table and all saturated waters. So here is unsaturated, and here we have all below water table is the saturated zone. So please review these concepts and and keep it clear so you can understand and you can identify the questions and how to address properly. the answer. Okay, this relationship is important. You can read through. Please read about the runoff and coefficients, characterizations of rainfall. I don't want to go through specifically point by point, so you can read all this material, but please study carefully. The part that I would mention, I think here we can summarize all this information in these four graphics. So how can we see the effect of different variables depends on the watershed conditions. For example, here we have hydrographs, time on X, discharge on the Y's, X's, and here we have a small watershed. So how is the size of drainage basin influencing the type of hydrographs or the patterns that we can see in the hydrographs? In a small watershed, we can have a lag time, so this peak is faster. I could see it before, and we can have a slower runoff. Here, for a larger basin, we will have a longer lag time, so we will see this peak later. We will see this maximum runoff later in time for a bigger or a larger basin. For a vegetation, I think is very clear. When we don't have vegetation, usually the runoff is higher and the lag time is shorter. So we will see that a high we will see high volumes of runoff uh, much more quickly, faster than when we have a forest. Usually, the forest the water can intercept the rainfall, and we can see that the forest helps and is like a buffer of that effect, can absorb part of this water. Part of this water can be sipping and can percolate in the soil, and the effect is smoother. That way we don't have vegetation. Similar when we have impermeable soil, so the water cannot percolate, cannot seep into the ground, so we have a higher runoff. So that's basically what we can see. Where do we see a higher runoff or a faster or a first effect? When we don't have vegetation, when we have a small basin, when we have a steep valley, or when we have impermeable rocks. So here we can involve all the variables and parameters. We also saw this, so please review these concepts. What is the base flow level, rising limb, crest, and falling limb? Just to identify, it's here in the notes, and you will read it, or probably you have already read it last week. What is influencing the base flow? The base flow is influenced usually by the groundwater, so it's more I could say it's independent from precipitation. Storm hydrograph components, we can review these concepts, but it's the same that in the graphic, so I'm not gonna stop there. I'm just trying to guide you through the material that we have already covered, so you can identify which are going to be the main points for the quiz, which I think is important. So here we have a summary of the effects of urbanization on storm flows. Later in this week and in the following week, we will see the effect of that and calculations. In the quiz, we will have only one calculation, and it's about this rational method. So please keep clear all the concepts. This is discharge, the coefficient, the maximum rainfall intensity and area. And we need to calculate. As I mentioned in the tips, please always keep track of units. This is very important. I mentioned here in different units because this is what we usually see in the reports. So when we see a report, we see the peak runoff in cubic meters per second. And when we talk about maximum rainfall intensity, when we do field work, when we use all the measurement tools and equipment, we get the information in millimeters per hour usually, and area in square kilometers. But we will need to transform so we can keep track of units, and we have all the variables in the same units. And that's it. That's what we need to do. There is an example. I'm sure you read it last week. So that could be all that we are going to cover in the quiz. As a summary of this, what I want to review is what we have learned during these first weeks of sustainable hydrology. As we saw it in Bright Space, is basically what we have seen, what we have summarized in the lectures, lecture 1, 2, 3, and 4, and basically one link in week 3 that we need to study. We also involve concepts of stormwater management and what happens when the land use and or precipitation changes. So this is what it's going to be, what we'll see in the quiz. We will see content from week 1 to 4, and it covers topics from these weeks, so you can study the lectures and you will have the material that you need to answer correctly this quiz. There are 13 questions and you have 1 hour and 5 minutes. You have only one attempt to complete this quiz once, but you can save your quiz and finish it later. But the program will be counting your time. For example, you can do 20 minutes now, save it, and finish later. Yes, you can do that, but you will have only one opportunity to do the full test. So you have to finish it later. Of course, don't share your quiz answers, and please read the college policies about plagiarism and copy and um, all that legacy. And the quiz is an open book. Of course, you can check your notes, but please, I highly suggest you to study these lectures 1 to 4, before you start taking the quiz. Because if you are faced to one question and you start going back to your notes, you are gonna waste time. Probably you can waste time in one question, I don't know, 10 minutes trying to find the answer, and that is gonna affect negatively the rest of your answers and the timing for answering the quiz. So please review these lectures, and when you feel prepared, when you feel ready, start the test, and you have plenty of time. You have more than an hour to answer these 13 questions, which are simple but are basic concepts that we need for this course. The objective of this online quiz is to do this revision, is review all the basic concepts, the most important concepts that we need for our sustainable hydrology course. If you have any questions, concern, please email me. You can contact me anytime, and I will always answer as soon as I can, as soon as my other projects and other classes allow me to answer. So that's it. Next week we will see low impact development and agricultural pest management practices. As I mentioned, every week we are building a knowledge and we are incorporating all the concepts that we have seen. So that's why I recommend you to work on that the week, study that material so you don't accumulate content and you can be overwhelmed with work. Each week in this course, we'll have one assignment. But if you don't finish it on time, then you are going to have accumulative or pending tasks that probably are going to be a little bit overwhelming. So please always contact me or ask me if you need more time or if you have any issues answering or completing any assignment. And we will also have discussion 3. That's going to be for next week. Thank you very much, and I hope you have a very nice week. Please email me if you have any questions. Good luck with your test. Thank you. Bye.